Most men are of their time, but very few define it. One of those men is General Bernard Schriever. He can truly be called the father of the American missile and space programs. General Schriever led the team of pioneers whose efforts gave us the intercontinental ballistic missiles that today stand in constant readiness to defend our nation. His vision led to space systems that are now essential to support the global reach of our military forces, delivering data on weather, data to help us navigate, to help us relay communications, to gather scientific information, and to reinforce early warning systems. The technology explosion resulting from space research has also provided profound benefits to our daily lives, with important applications to the civilian and commercial sectors. That is today. But it all began with the groundbreaking accomplishments of the scientists and engineers under the leadership of General Schriever. In his 35 years of public service to his country in the United States Air Force, and especially his duties from 1954 to 1966, General Schriever set the course for the American ballistic missile and military space programs, a legacy that can still be seen today. In 1954, the Atlas ICBM was but a concept which a committee of America's most distinguished scientists recommended be developed as this country's highest priority. It was in this Cold War era of uncertainty that the Air Force assigned accelerated development of the Atlas intercontinental ballistic missile to an organization called the Western Development Division, commanded by then Brigadier General Bernard Schriever. These early pioneers began their mission in a converted schoolhouse in Inglewood, California. As development of the Atlas proceeded, a need arose for a backup ICBM design. An even more powerful and sophisticated liquid-fueled ICBM, Titan, provided a two-stage alternative approach to Atlas. Thor was initiated in late 1955, an intermediate-range ballistic missile for deployment overseas, while the more powerful intercontinental range Atlas and Titan missiles completed their more complicated development cycles. The first Atlas and Thor test flights had hardly been completed when authorization was received early in 1958 to undertake the development of a new generation solid-fueled ICBM, the Minuteman, eventually to become America's first line of deterrent strength. Thus, 4 separate ballistic missile systems were born. Thor would become operational in 1959, Atlas in 1960, Titan in the spring of 1962, and the first Minuteman in December of that same year. Even as these missile development programs were moving ahead, the far-reaching thinking and growing expertise of the Air Force missile men turned to another area, the orbiting of artificial Earth satellites in space. Thus, the Agena spacecraft was authorized in 1956, even before the booster power to place it in orbit had been tested in flight. The Atlas and Thor missiles were selected for modification to become our first satellite launch vehicles. In 1958, the Air Force space program under General Schriever used an Atlas booster to successfully launch the Project SCORE communications package, which led to other military space applications. A multitude of contractors, subcontractors, suppliers, plus thousands of scientists, engineers, and managers were mobilized into a complex space and missile program. General Schriever's team was supplemented in 1960 by the formation of the Aerospace Corporation to help with scientific and technical planning and management. National security drove the early development of the military space program. The Corona program, under the unclassified name Discoverer, was America's first photo reconnaissance satellite. Discoverer 14 was the first satellite to achieve full operational success. The vehicle carried a 20-pound load of film and photographed more than 1,650,000 square miles of Soviet territory. Corona had made a quantum leap in intelligence gathering by operating from the new high ground of space. The Air Force has placed many military communications satellites into orbit. The initial Defense Satellite Communications System, our first operational military communications satellite, relayed strategic voice, teletype, and even telephotos to and from Washington and our worldwide forces. Another group of satellites performed an even more active role in national defense, monitoring the Nuclear Test Ban Treaty. Bella satellites were capable of detecting nuclear radiation in space or on Earth. The Air Force has developed satellites that can detect and track intercontinental and submarine-launched ballistic missiles almost from the moment they are fired. Development of this satellite system has greatly improved our overall warning network and started with the MIDAS program for testing the use of infrared sensors in space. Another Air Force satellite system is making daily contributions to the lives of every American. The Defense Meteorological Satellite Program routinely provides its military weather pictures to the public through the National Oceanic and Atmospheric Administration. Just as Air Force booster power is required to orbit these military satellites, so too is a method for commanding and controlling them and gathering their data. The Air Force Satellite Control Facility is responsible for monitoring Department of Defense satellites in orbit and, through its worldwide network of tracking stations, commanding them to gather the required information and then collecting that data for analysis and use. Closely connected to this tracking network are the Air Force's launch facilities. These two major launch facilities at Vandenberg Air Force Base and Cape Canaveral were both created specifically to handle our ICBM and space launches. Vandenberg is the ideal launch site for satellites in polar orbit and for ICBMs down a heavily instrumented test range to impact into one of several quiet Pacific Lagoon target areas. Cape Canaveral is the site of our initial ICBM test launches, along with flights of Air Force satellites being boosted into equatorial orbits. In April 1957, General Schriever's portrait graced the cover of Time magazine. Time called him America's Missile Man, a very distinctive honor. It has been 30 years since he retired from active duty, and over 40 years since he started this country down the road toward the space age. Every facet of our national defense missile and space programs have the marks of his guiding hand. General Bernard Schriever truly can be called the father of the American ballistic missile and military space programs.